Welcome to Connect, where we care. Connect is a USA-based care provider. We solve the problem of childcare services and elderly care. We wanted to create a space where individuals can seek out care of all needs and find employment to help those in need. We have services for all ages. Connect ensures that our employees have adequate work experience and get paired with the right person in need. So first, let's jump into our presentation. We will have Samrat share our findings about the conceptual model with our main entities and relationships. Then we will have Prateeksha run us through our pseudocode and with our primary key constraints highlighted. Chinmay is going to share key aspects of our DDL and DML with examples from our tables. And then finally, we're going to talk about some challenges we ran into and highlights of our team. And with that, Samrat.
Thank you, Annie. That was a great pitch. So on this slide, we are just sort of putting out our entire entity relation diagram, and then following slides will talk more details about it. So we did create multi-value attributes for customer phone numbers, emails, payments, and employee skill types. In addition to that, we do have some of the weak entities which actually depend on the main entities. So payment methods, which actually depend on employee, and skills, which actually depend on the payment method depends on customers, while the skills depend on the employees. Next slide, we'll talk about the associative entities. So client and employee does have many-to-many relationship, and that's where the relationship between them is an associative entity. So subscribes, is assigned, and works for is what the additional associative entities that we have as part of our entity relationship diagram. Moving forward, the total participation, as you can see here, the client and the customer. A customer can exist only if he pays for the client. So that's where the client has total participation from his side in the relationship. And then we are having the attribute relationship with customer just to track what relationship a customer has with the client. So total participation, customer, client, subscription, service, and employee. So these are the total participations in our entity relation diagram. Going forward, specialization with the super types and subtypes. We do have employee, which actually is sort of parent class, and then hourly employee, salaried employee, and contractors are the subclasses where the common parameters are shared, or common attributes are shared at the employee level, and we even have the skills, which is actually there for targeting the specialization of a particular employee. So this brings to us to the specialization with super types and subtypes that we have as part of our entity relationship diagram. And from here, I'll request Prateeksha to take it forward and talk about the logical design or pseudocode of our entire database. Thank you.
Thank you, Samrat. That was indeed a very detailed explanation. So now this is the logical database model, or the pseudocode, which we came up from the entity relationship diagram, which Samrat has explained. So mainly we are focusing on 4 tables. One is customer table, another one is client table, employee table, and a service table. So for the customer table, customer ID acts as the primary key. For the service table, service ID acts as a primary key. And for the employee table, employee ID is the primary key. And for the service table, service ID is the primary key. So based upon these 4 main entities, we have few other entities such as client service table, wherein it's a combination of both client table and a service table. So service ID in this case would be a foreign key. And then we have an employee skill table, which depends on employee table as well as the skill table. So the employee ID would be a foreign key in this case. So this is how we came up with a combination of these 4 entities. So overall, we have around 15 to 17 tables. So Chinmay is going to take it forward from here. Thank you.
Thanks, Prateeksha. That was a great explanation of the logical model. So I'll be talking about the different tables that we have used in the database, a total of 17 tables. And primarily there are 4 tables in our database. The first one is the customer table, which is basically who will enroll his or her dependents into this program, the services. The customer table has data on the customer ID, SSN, the names, date of birth. And for every table, we have tried to incorporate a different column which will help us enabling analytics into the future. Over here, it's job title. So the next table is about the client who will actually get enrolled into the different services. It is mapped to the customer ID, and it has different columns like first name, last name, its birth date. And also we have tried to incorporate 3 tables over here, allergies of the, which will give us information about the allergies of the client, if the client has had any surgeries, and also any medications, and also the relation with the customer. So we have tried to demonstrate messy data of the real world by keeping some of the columns like the rows empty, so which demonstrates real world data. The next table is the employee table, which will have information about employees of our company. It has information on employee ID, which is a primary key, first name, last name, and a qualification in terms of their educational degree, and also lists the hire date of the employee. So if you can, yeah. The next table is about the services offered by the company. We offer 3 different services, which are denoted by different flags: adult care and child care. These are denoted by flags. The first service will have just adult care, the second one will have just child care, and third one has both. So this is about the service table. The next one are a list of tables that we have in our database, which are client service, which maps the service ID with the client and the client ID. Customer subscription lists the subscriptions taken up by the customer. Payment method, these 2 tables have all the subscription data of the payment data of the customer. And we have 3 different tables, which categorize as salaried employees, hourly employees, and the contractor. The next one is a trigger, which basically tracks the number of hours worked by an employee. You can see it's a log table basically. If we go forward, then we have implemented a stored procedure after this, which basically updates the salary of employees for a particular employee ID. So from here on, I'll request Prajwal to take it forward from here. Thank you.
That's an awesome explanation, Chinmay. When we began developing our SQL queries, basically the select queries, we thought of getting some insight and of the data and how our data is flowing around, and also on how the architecture is. But when we built views, it was more about what kind of business insights we can give when we build the applications out of this database, like a web application or a mobile application later on. So I have given a few examples of our views here. Maybe when we build an admin dashboard for this application, we might need data of the subscribed customers, like what kind of customers have been subscribed and what kind of subscription they have. So having that data will help us get the type of subscription we can recommend to the customer, also when their subscription is going to end. Then the other view which we have is the fresh hires. So we try to get the fresh hires out of the list. Then we can give them the certain set of trainings which we need to give. So that was the other view. So when it comes to challenges was more of we had like 2 things, like technical challenges and our the team collaboration part. So when technical challenges, we had issues in ERD diagram and the cardinality, especially adding one-to-one relationship, one-to-many relationship, things like that. And team collaboration was difficult because people had other works as well, like most of them are employed. Because of it, we had the challenges, but we ended up pulling it out at the right time and the right spirit. So this is our team, as you can see, like the happy faces at the end of the collaboration and pulling out the project. I would like to thank Professor Jacob for helping us with the technical and the collaboration aspects, and giving this opportunity to build a good project and get an experience of the teamwork. And thank you one and all.